remember E equals mc squared,
Yes.
right? So if the energy is exactly equal to the mass of two muons, one muon and one anti-muon, then the energy is going to dump into muons and anti-muons. That field is going to take over, and you're going to get a muon and an anti-muon. And so what this ends up being is you get a collimated meaning it's all in one direction, and it's a muon beam.
Yes.
Okay?
Yes. This is out of Lawrence Berkeley National Lab and was published in the Physical Review, Accelerators and Beams.
Yeah, the basic idea is in order to make muons, usually you need like extremely large particle accelerators. Okay. And these guys have done it in effectively the size of like a lab, maybe a big lab, but it's still not like, the size of CERN or like SLAC, where it's like, hundreds and hundreds of meters worth of stuff to create a muon beam. And that becomes really, really relevant if you're trying to use muons to do CAT scans on very large things. For example, the pyramids or a volcano. So muon is a central part of the standard model of particle physics. It's kind of like a heavy cousin to the electron, okay? A heavy cousin. Here, they've created an electron gun, effectively, that is extremely fast, very, very high energy electron guns with a short rifle in some sense. A massive, really highly energetic electron beam. Now what you're gonna do is you're gonna dump that beam into a giant block of lead, steel, and concrete, okay? And what that's gonna do is the electrons are then gonna interact with these heavy nuclei. Lead is a very heavy nucleus, right? And as it interacts, the electrons are gonna slow down, and they're going to slow down, creating radiation. Because remember, we've talked about this a lot. If a charged particle accelerates or deaccelerates, it's going to release energy.
Yes.
Right? The only time somehow that it doesn't do this is in the confines of an atom, right? Because that's when
stuff gets weird.
Yeah, all the rules are off. But if it's a free electron and it's moving and it starts accelerating or deaccelerating or changing direction, it's going to create this thing called Bremsstrahlung. It's a German word for breaking radiation, okay? So all of that energy of the electron is going into high energy photons. These are gamma rays. And now those high energy photons will interact with the atomic nuclei to create pairs of particles. Pair production is something that happens when you got a bunch of energy in one spot, and that energy spontaneously splits into two particles. One that is the matter part, one that is the antimatter part. You get the matter-antimatter pair. And if the physics is right, then you're going to get a bunch of matter-antimatter pairs that are exactly muons and anti-muons. Mm-hmm. Okay? If you tune the energy such that the energy is exactly E divided by C squared, the mass,